Hello everyone, so today we're going to solve the problem of the day, rod cutting, in which we have been given a rod of length n, and we can cut the rod into pieces and sell it, and we have to obtain the maximum obtainable price. So the length I, in any case, in the area of price, the length I denotes the length of the inch that we can cut the rod into, and the corresponding is its price. Right. So if we look into the first test case, we get to see the prices at 1, 5, 8, 9, 10, 17, 17, and 20. So since we have been given that, we have to consider one base index in case of rod length. So 1, 2, 3, 4, 5, 6, 7, 8. So let these indicate the length of rod, and these indicate the price of the corresponding lengths. So what we can have is we can cut the rod into the inch of 7 length and of that one, and if we get the value of such price of such length, so we can have for 7-inch rod we obtain the 17 unit of price, and for the 1-inch rod we get 1 unit price. So the total valuable amount we get obtainable amount is we get 18. So we have to maximize these things, right? So what are the possible cases? So there are numerous possible cases. We can decide to cut the rod into 8 pieces of ones, right? 8 pieces of one, or we can cut the rod into two, length of 2 and length of 6. So we have n equals 8. Here also n equals 8, and also we can have the rod of length 2s of number 4. In that case also we have the rod of length 8. So what we can do, so if you look closely, we have the problem of take or not take, in which we can decide to take this. Suppose if we look into this test case, we can decide to take, to cut the rod. Take simply means to cut the rod in, uh, to cut the rod, or not take means not to cut the rod. All right. So if we decide to cut the rod, yeah, so then we cannot cut the rod into any further pieces, right? If we have cut the rod into 8 8 inch, then we have no length left, so we can only sell that 8-inch rod we have cut, which means we have not decided to cut, right? Since we only have one piece, so it is the rod itself. So if we sell that 8-inch rod, we get the value of 20. So if we decide not to cut that rod, means if we decide to cut the rod, suppose in the 7-inch and 1-inch, so this clearly means we have not decided to cut the rod or to sell the rod at age 8 inches, right? So this is a basic take not take problem. So in order, so as you can see, as you have guessed, that this problem is of dynamic programming, since we have to maximize the profit, right? So what I'm going to do is to write a recursive function first, in which I'll be passing my price array, my size of the price array, and the index, which will be nothing but my traversing variable. So what I'm going to do is to place my index here first, and which will be which will be what can I say, the traversing throughout this array, and since we cannot traverse with n, right? So I have to take a variable index, and I have to check if we can cut the rod. If yes, then I will decrement the rod length by the index, and if we cannot, then we move the index onto this one, this 7. And suppose if I again decided not to take this 7-inch rod, then I'll move on to here. So my index will be traversing throughout this array, right? So let me write the solve function in which I'll be passing the parameters. And in any case, if my index is at has reached 0, then I return. Index 0 means only I have the rod of length 1, right? So I can cut the rod into this 1 multiplied by whatever the n is. Suppose here n is 8. So I can cut the rod into 1 multiplied by 8 pieces, right? And the value I obtain is the price for selling this 1-inch rod, which is nothing but 1. Yes, in this case it's 1. So 1 multiplied by 8 is 8. The value I can get of selling 1-inch rod of number 8 is 8. So it is nothing but n multiplied by price at 0. And will be having two variables, int take, which will be initialized to 0, and int not take. And so in the not take, we decide not to cut the rod, right? Not to cut the rod. So in that case, we will we won't be having any price to gain, right? We simply call the recursive function with price n, and my index will now point to the next value, right? Suppose if it were here, it will now point to this 7. So it will decrement its value. And now we have a condition to take for cutting the rod, right? If my rod length is greater than n, then how can I cut? If my cutting rod length, so let us take a variable int cutting rod length. So it will be nothing but this index with an incremented value. Since my index is 0 based and the rod length cannot be 0 based, here it is written that I have to consider 1 based indexing. So my rod length will be, cutting rod length will be 1 based indexing. So if cutting rod length is nothing but the size I'm about to cut the rod. So if this value is greater than my size of rod, length of rod, then I can't do anything, right? I can only cut the rod if my cutting rod length is less than or equal to n. So I can I can cut the rod and gain the price as price at that particular index with the solve function, and we won't be decrementing the value here. We only be decrementing the size of our rod since we have taken the since we have cut the rod, right? So the length will be decremented, and index won't be changing since we can have infinite number of supplies. Suppose we have 8 times, right? So I can have um, duplicate number of I have infinite supply of rod. That's as simple as that. And at last I've returned maximum of take and not take. So let us run. So we get the output correct. But if we submit our answer, then we will get CLE. Since it is exponential, it has exponential time complexity. So now let me write the memoization code. So in memoization, the first step is to create an array. The size of array will be the number of changing parameters, which means simply means here if you see the n, our n is changing and our index is changing, right? So our index, sorry, our array will be of size 2 dimension, vector of n of output of n plus 1, size n plus 1. Since our n is varying from 0 to n, and our, what to say, the, what is it, our index is varying from 0 to n minus 1. So I am taking the sizes as n plus 1 cross n plus 1. So if you don't know, that's how you declare a 2D array. And I initialize all the elements as minus 1. Now let me pass this onto my solve function. Let me pass it by reference. Now let me check if answer already exists. So how can I check that? If output at position n and index not equals minus 1, this means I have my answer stored. So I return my value, my total price present at that index. And in the end, after calculating the answer, I will save my answer in my this place. So let me compile and run. Now let us check if we have any bugs or errors. So let us submit. Yeah, we have solved this problem. Thank you.